So we now continue discussing the properties of logarithmic functions. And so this is just a continuation of what we started last time. So here's first example. All we want to do is like practice, at least for the first half of this lesson. All we want to do is practice on manipulating logarithms and on using the properties to simplify things, to rewrite things, to make them simpler or condense them, expand them, um, all sorts of things. Just get used to dealing with logarithms and the properties. Okay, so the very first one says use the properties of logarithms to expand each of the following expressions. Okay, the very first one says logarithm base 7 of x to the 6th y to the 8th. The base 7 there is really, for the most part, completely irrelevant because the properties of logarithms are the same. The basic properties of how you manipulate logarithms are the same regardless of the base. So that 7 there is really completely irrelevant. This problem will be solved exactly the same way if instead of a 7 I had a 5 or a 3 or a 2 or whatever. So that is going to have no bearing on this problem and how we solve this problem. All right, so we're going to expand this. Right now it's a single logarithm, so we're going to expand it. Okay, the first property is that if I have the logarithm of a product of two things, and there's a product right here, x to the 6th is being multiplied with or by y to the 8th. So there's a product right there. So the property says that whenever I have a product inside a logarithm, I can expand that as a sum of two logarithms, namely the logarithm of the first thing that is in the product plus the logarithm of the second thing that is in the product. Okay, so remember the property is that if you have the logarithm of base b of two things being multiplied in there, so you could say x times y, then you could expand that as a sum of two logarithms. And that actually works not only for two things being multiplied. If I had actually three things being multiplied in there, I can expand it into a sum of three things. So this would be log base b of x plus log base b of y plus log base b of z. So it doesn't have to be just two things. If you had more things, more more factors in that product, you could keep expanding. Okay. So anyway, so I have that. So that's the first property. Then we can apply the property that says that if I have a power inside a logarithm, like this one, x to the 6th, then you can bring that exponent all the way to the front. So we're going to bring that exponent all the way to the front in the next step. So I'm going to move that to the front, and this 8, I'm going to move it all the way to the front. That was one of the properties. So then this is going to become 6 logarithm base 7 of x plus 8 logarithm base 7 of y. And that is the end of that. There's nothing else you can do here. So this logarithm, that was a single logarithm, has been expanded into 2. So that's expanding. That's what they were asking for. You expand it into simpler logarithms. And you might ask, why in the world would you want to do that? Well, first of all, this logarithm is simpler than that. First, because this one has exponents, big exponents. I mean, if you try to compute 3 to the 6, that's already pretty big, or 3 to the 8. So exponents makes things more complicated. So this one doesn't have any exponents whatsoever. So is in a sense simpler to evaluate. And another reason is when you take calculus, if you have to take calculus, taking the derivative of an expanded logarithm like that is easier than taking the logarithm of a condensed, than taking the derivative of a condensed logarithm. So taking the derivative of this thing is easier than taking the derivative of that. In other words, applying calculus to the right-hand side is easier than applying calculus to the left-hand side. So it's a skill that that is worth uh, knowing because you're going to use it if you're going to go there. All right. So now let's look at this one. It says the logarithm of, and then you have that complicated thing. Okay, again, we're going to expand it. Now we're going to apply the rules for logarithms, not for products, but for quotients. I have a quotient right there. So remember, it says if you have the logarithm of two things that are being divided, then you can say, we write this as the difference of the logarithm. So the logarithm base b of x minus the logarithm of base b of y. So the logarithm of the top minus the logarithm of the bottom. And that's what we're going to apply in here. So this is going to be the natural logarithm of the top, which is the fifth root of x, minus the natural logarithm of the bottom, y squared square root of z plus 1. That would be the first step. Okay, now we keep going because there's more stuff to do. The fifth root, you can write that as a rational exponent. So you can write the fifth root of x as x to the 1/5. And you can do also the same with this one, minus ln of y squared. And then you can write this square root as a rational exponent. So you can write it as z plus 1 to the 1/2. Okay. Now, so now there's multiple things you could do, but I'm gonna do everything just one step at a time, so I don't lose you. I'm gonna leave this one the same, so I'm not gonna touch this one yet. But what you could do here is apply the property that says if you have an exponent inside a logarithm, you can move the exponent to the front just like we did here. Okay, we're gonna do that in a minute. But here, there is a product. You're multiplying y squared times this thing. So because there's a product, I can do this, what I did here, which means I can expand this product into a sum of logarithms. And remember, that minus is going to affect what I do here, so it would be best if I just put a bracket there to remind me whatever I do here, that minus is supposed to affect everything. So this is going to be ln of y squared, and then there's a product. So it's sum ln of z plus 1 to the 1/2. Okay. And now I'm going to distribute that minus. So this is going to be ln of x to the 1/5 minus ln of y squared minus, because I'm distributing the minus, ln of z plus 1 to the 1/2. All right, and lastly, I can apply that property of moving all the exponents inside the logarithm all the way to the front. So now we're going to move that 1/5 to the front. We're going to move that square to the front, and we're going to move this 1/2 to the front. So it's going to end up being 1/5 ln of x minus 2 ln of y minus 1/2 ln of z plus 1. And now that is the end. You cannot expand that. You cannot do anything with this. You cannot split that up. There is no property of logarithms that allows you to split up a sum or a difference. Only a product or a quotient. Only a product inside the logarithm or a quotient. You cannot split up a sum inside a logarithm. So if you have something like this, you're stuck. You cannot do anything here. This you cannot split that. This is not going to be log of x plus log of y, because that is the property for the product, not for the sum. So don't make that mistake. That's wrong. All right, so that means that I cannot do anything with that, so it's over. So the answer is this. All right, and now let's do the very last one. Let's expand this one now, simplify. So now again, I have a quotient. So this is going to become the ln of the top minus the ln of the bottom. Okay, now this is, you can rewrite this as a rational exponent. So this is ln of x to the 1/4 minus ln of 2 y cubed z. So in the next, in this step right here, all I did was rewrite the fourth root into rational exponent. Okay, then I'm going to, before I move the 1/4 to the front, I want to take care of something here. There's a product of three things here. Three things are being multiplied. The 2 times the y cubed times the z. So we can actually expand that into a sum like here. When you have a product of two things, you can expand it into the sum of three logarithms. So applying that property here, this is going to be, and remember that minus is going to affect everything I do, so put a bracket. This is going to be ln of 2 plus ln of y cubed plus ln of z. Because it's 2 times y cubed times z. So there. And now we're only 2 steps away. Now we're going to distribute that minus across this bracket. So this is going to be ln of x to the 1/4 minus ln of 2 minus ln of y cubed minus, minus ln of z. Okay, minus ln of z. And lastly, now I'm going to bring all those exponents, so this one and that one, all the way to the front. So that one goes to the front, and this one goes to the front. So it's gonna end up being 1/4 ln of x minus ln of 2 minus 3 ln of y minus ln of z. And that would be the end. Okay. I have put here in this table, I don't know if you can call that a table, but in this list, common mistakes, please do not make these mistakes. Just memorize the rules as they are. If it's not on the list of properties of logarithms, if it's not one of the rules you can apply, then it's not true. Okay, so memorize them precisely. So logarithm of a sum, you cannot do anything with that. I just told you that's wrong. You cannot do anything. If you have logarithm of the sum, that's it. You can, I mean, for the most part, unless there's some other algebra trick you can deploy to simplify a factor. If you factor, you're expressing it as a product, and then you can apply the product one, the rule for products. But if it's just a sum, you cannot simplify further. You're stuck. You cannot do anything with that. You cannot expand that. Remember that expanding a product is not a product, is a sum. So that is going to become a sum, not a product. A difference, you're stuck again. Difference are like pluses. They're the same nature, so you cannot expand that. And if you have a quotient, remember it's not the quotient of the logarithms, it's the difference of the logarithms. And you can go over these later on your own with actual concrete numbers that show you why it's completely wrong to do such a thing. And lastly, when you see this notation, that when you see that on exponent like this, that, for example, this one, this 4, that's for the 2 that is inside. It's not for the whole thing. Okay, so let me write that. So if you see something like this, log base 2 of x to the third, that 3 is only for the x. Don't make the mistake of thinking that the 3 is for the whole thing. It's not true. Okay, so don't make that mistake. So this one would have been the same as having this. That 3 is only for the x. Okay, now let's do some more exercises where we continue practicing the properties of logarithms. Now we're going to go backwards. We have 2 or more logarithms, and we're going to condense them into a single logarithm by using the properties. So we're going to be using the same properties, but we're going to be using them backwards. All right, so here's the first one. It says 1/7 log base 2 of x plus 3 times log base 2 of y. So the first thing you want to do is take coefficients and put them inside. So put that 1/7 inside, and the 3 also moves inside. When you move it inside, you move it as an exponent. Okay, so that means this is going to be logarithm base 2 of 7 to the 1, sorry, logarithm base 2 of x to the 1 over 7. And then the next term is going to be log base 2 of y cubed. And you can put parentheses if you want over there to make it extra clear. So move the coefficients inside the logarithm. When you move the coefficients inside the logarithm, you move them in as exponents. They become exponents. And now you can combine these two logarithms because they have the same base. If they didn't have the same base, I couldn't do anything. I couldn't combine them just like that. So because they have the same base, I can combine them, and you can combine them by just multiplying them. So this is log base 2 of is going to be 1 x to the 1 over 7 times y cubed, and that's the end. I mean, there's not much else you could do. You could perhaps write this instead of using fractional exponents, using the radical form of that, but that's not necessary. I mean, they're equivalent, so they both are correct. But, okay. Now let's do this one. All right, again, you take coefficients and you move them inside the logarithm. When you have coefficients and you move them inside the logarithm, they become exponents. So this is going to become log of a to the 4 minus and then I'm going to move the 5. I'm going to leave the minus in between in between the logarithms in there, but I'm going to move the 5. Minus log b to the 5. And remember that when there's no subscript for the logarithm, like in here, in engineers understanding, that means there's a 10. So this is logarithm base 10. Okay, and now if we can finally combine these two logarithms, when you have a difference of two logarithms, you can combine them as a quotient. So it is using this property. If you have a difference of logarithms, you can condense them into a quotient. So it's using this property backwards. So from right to left. Okay, so using that property, we're going to get logarithm of a to the 4th over b to the 5th. And that is the end for that one. And the very last one. You should pause the video and try to do this one on your own. That's my recommendation. Okay, let's do it. Take coefficients and move them inside. You move them inside as exponents. So this is ln of x, not x cubed minus, now the 2 goes inside as an exponent, so minus ln of y squared minus, and then the 1/4 moves inside as an exponent, z to the 1/4. And you don't have to put parentheses, but if it makes it more readable, you can. Okay, and now there's many ways you can tackle this. You can take the first two. That's a difference. So you could do ln of x cubed over y squared. Again, I'm using the same property I just used in this one. A difference of logarithms becomes a quotient. So the quotient of those minus, and then just leave this one as is. We'll take care of it in the next step. And now it is going to be this over that, or this divided by that. Okay, before I write it in there, I'm gonna make that calculation in a separate piece of paper. So we have x cubed over y squared divided by z to the 1/4. Divided means that you multiply by the reciprocal, so times 1/z to the 1/4 times 1/z to the 1/4, and then you multiply across, so this is going to be x cubed over y squared z to the 1/4. So actually then, when you divide this by that to form the quotient, this is what you get. So this is going to be the ln, I'm just going to copy that here. This is going to be the ln of x cubed over y squared y squared times z to the 1/4. And now that's the end. I have condensed 3 logarithms into a single logarithm. And there's nothing else to simplify, although you could write this z to the 1/4 as the 4th root of z, using radicals instead of fractional exponents. Okay, that's the end for that example. Now, how do you find the natural domain or the implicit domain of functions that have logarithms in them? Well, you have to follow the bullet points that we learned a while ago. for how to find for finding the domain of functions. But now we're gonna incorporate the third bullet point that I had. Remember that we had three bullet points, and the very first two are the ones we concentrated back then, because the third bullet point concerned logarithms, and we didn't have logarithms back then. But the third bullet point was that if you have logarithms, things inside logarithms, if you have a logarithm, things inside logarithm need to be positive. So whatever that is, you have to make it bigger than 0, and you're going to solve this. So that was the third bullet point. If you are looking for the domain of a function, the first bullet point was fractions cannot have 0 on the bottom. So if you have a rational expression, the bottom cannot be 0. So you find all the x's that make the bottom 0 and discard those. The second bullet point was if you have radicals of even index, then the inside has to be bigger than or equal than 0. So you set it bigger than or equal than 0, and you solve that. If you have of even index, and then the third bullet point is if you have logarithms, then things inside the logarithm need to be positive. So you make it bigger than 0. You set it bigger than 0, and you solve that. Okay? So, for example, let's start with something simple here. So, find the domain of this. This says f of x equals ln of 2x plus 2. Well, the first two bullet points do not apply because there's no fractions, there's no rational expressions. So that does not apply. The second bullet point was if there's radicals of even index, well, there's no radicals of even index, so the second bullet point does not apply. The third bullet point is if there's logarithms, then whatever is inside the logarithm needs to be bigger than 0. So that means we need 2x plus 2 to be bigger than 0. We're going to set 2x plus 2 to be bigger than 0, and we're going to solve that. Okay, now let's solve this. This is move the 2 to the other side, so you get 2x bigger than a negative 2. And now divide by 2. So divided by 2 gives me x bigger than negative 1. 2 divided by negative 2 divided by 2 is x bigger than negative 1. And that is it. That is the domain. That is the domain in inequality notation. So remember, there's two ways we're going to be reporting the domain. You can report it in set Builder notation. The set of all x is such that x is a real number and x is bigger than negative 1. Or the other way you could report to the answer is using inequality notation. In the set of all numbers bigger than negative 1, bigger means to the right of negative 1, would be from negative 1, comma, to infinity. So in interval notation, that would be the answer. You want all numbers bigger than negative 1 or numbers to the right of negative 1. So from minus 1 to positive infinity. Okay, here's another one. See, that one, again, the first two bullet points do not apply. There's no rational expressions, there's no fractions, and there's no radicals of even index. So the first two bullet points do not apply, only the third one. And the third one says that anything inside a logarithm needs to be bigger than 0. So you take that 10x minus 5 and you set it equal bigger than 0, and you solve this. So move the 5 and divide by 10, and you get x is bigger than 1/2. So the answer in interval notation would be from 1/2 to infinity, because you again want the numbers bigger. Any set building notation is basically just write the brackets instead of all x such that x is, and then you write x bigger than 1/2. All right, and last one. Let's go over the bullet points. This one has 2 bullet points that apply. The very first one that says if you have fractions or rational expressions, the things that are on the bottom cannot be equal to 0. So we need first bullet point, x minus 1 cannot be 0. So you set it equal to 0, you solve it. So that means x equals 1 is the number that makes the bottom 0. So this number has to be discarded. Okay, that number has to be discarded. You cannot have x equals 1. Not part of the domain. You cannot plug it in. And then second bullet point, if there's radicals of even index, the inside has to be bigger than or equal to 0. That does not apply here. And then the third bullet point is that anything inside the logarithm has to be bigger than 0. So you take that 3 minus x and you set it bigger than 0, and you solve this. Now let's solve this. Move the 3 to the other side and you're going to get negative x bigger than negative 3. And now divide by negative 1. Remember that when you divide by a negative number, the inequality sign is reversed. So you get x is less than 3. And now we have to put these two things together. So I have 1 and 3. 1 and 3. So 1 I don't want. So draw a hole there. And 3 you don't want either because that's not included. So 3 you don't want it either. It says you want numbers less than 3. You don't want numbers equal to 3. So you cannot include 3. And then you want all numbers less than 3. You want all numbers less than 3. All numbers to the left of 3 except 1. 1 is you're going to skip over. So that means you want all of these numbers smaller than 3 or to the left of 3 except that one that we're skipping over. So that means the answer is these two black pieces, shaded pieces. So the answer is going to be from minus infinity to 1, parentheses because I'm not including 1, union 1 to 3. That is the answer in interval notation. Next, we want to talk about a little formula that allows you to change bases. So if you have a logarithm that is a base, let's say base 5, you can change that logarithm to a logarithm of another type with another base, so whatever base you want, actually. So if you have a logarithm base 5, you could change it to a logarithm base 10, base e, base 2. You can change it to whatever base you want. And that is a formula for how to change bases. So suppose you have a logarithm that is base a, okay, so something like that. And I want to change that to a logarithm base b. So how do you do that? Well, this is how you do it. Logarithm base b of x is going to be that I have there over and then you write logarithm base a, which is the original base. So this is the original base. This is the new base I want to change it to. And so logarithm base a of b. So that right there is the formula. That's how you change between logarithms. So you don't have to memorize that formula. You can have it. I would normally give it on a test. So you just keep it around when you're doing homework and the test. But if you wanted to memorize it for whatever reason, it's really not hard to memorize, and here's why. So just give me 10 seconds to explain. Here's why. Because basically, if I have something that is logarithm base a and I want to change it to logarithm base b, then really you can just change it. You can just write this in terms of the logarithm that you originally have, same base, and then what goes here, top and bottom, is precisely these same numbers that you see here in this exact same order that you see. X on top, B on bottom, because this is B is like a subscript. So X on top, B on bottom, and then you write logarithms of both the logarithm that you originally had. All right, so we're gonna change some logarithms now to use that formula. All right, so use a calculator for this one and change the base formula to be able to put in the calculator and approximate the value. The thing is, um, if you have a logarithm that is not base 10 or base e, then you cannot really evaluate it in a lot of calculators. So if I asked, what is that? Well, that's not going to be as easy to do because the 3 is not a power of 2, so you cannot do it like the other ones that we did without a calculator. So the only thing, if you ask me what is that, the only way I could figure that out is to put in the calculator. But the calculator doesn't have buttons for base 2. At least not this one, and many calculators do not have it either. So what we need to do is to change it to a logarithm that is to a base either 10 or e. You could change it to either one. It doesn't matter because both of them are in the calculator. So as long as you change it to uh, a base that is either 10 or e, then you should be good to go because you can put in the calculator. My preference, however, is to change it to base e. So that's what I'm going to do. All right, so we're going to change this to base e. So that means the natural logarithm, ln. So I just put ln here. And then top and bottom are the 3 and the 2. And that's it. Now I can put this in the calculator. So let's do that. So ln of 3. So in this calculator, you enter these backwards. So you enter the 3 first and then the ln. So I'm going to enter 3 and then the ln. That's ln of 3. And then I'm going to hit divided by, and then I need to put ln of 2. And again, I enter it backwards in this cheap calculator. So I put 2, and then I hit ln. And that number is the ln of 2. Hit equal. Say you're done. The final answer is that. So this is 1.58. We're going to approximate. Well, it doesn't. The instructions don't really say, so I'm just going to approximate to 4 decimals. In the homework, it should tell you. So I'm just going to write 4. Let me use 5 decimals. 9, 6. 58496. Okay, that's it. All right, so that is very simple. Now let's evaluate this one. It says logarithm of pi base 9. So you can now change this to ln by just write ln, and then just write these numbers in the same order you see them there. So it's like pi, it's almost like pi is on the top and then 9 on the bottom because 9 is a subscript. So you write pi 9. And now we can put this in the calculator. Let's see what we get. Alright, so again backwards. So where's my pi button here? Right there, pi. That's pi. Now I hit it with ln divided by ln of 9. So I hit 9 and then the ln. That number right there is the ln of 9. And then I'm done. So equal sign and then you get 0. I'm going to use 5 decimals again. 5, 2, 0, 9, 9. Round it to 5 decimals. Okay. And now you should pause the video and do that one. Make sure you got it. It should really take you just like 15 seconds or less. Alright, so this is going to be ln. On the top, you put a 10. On the bottom, you put a 7. And now I can enter that in the calculator. This is 10. Hit it with ln. Divided by 7. Hit it with ln. So that's the ln of 7. And then equal sign. And you get 1.18. 3, 2, 9. Okay, so I changed all of them to ln because that's my preference, but you can put here any logarithm. You can put base 10, which will be this button, uh, or any base that you're asked to do. But if the point is to put in the calculator, then you're only going to use base 10 or base E. All right, now we would like to continue practicing the properties of logarithms to expand or simplify each of the following. So this is more examples of what we have already done. Okay, so this is nothing new. So we're gonna practice some more. All right, first one, ln of 25x. So that's a product right there. You multiply 25 by x. So if you have a product, then that becomes a sum of logarithms. So this is logarithm of 25 plus logarithm of x. ln of 25 plus ln of x. And you could actually, even though that's not bad, you could actually simplify this just a little bit more. If you remember that 25 is 5 squared, so this is going to be ln of 5 squared. So again, I can rewrite the 25 as 5 squared plus ln of x. And now use the property that I can take exponents and move them to the front. So move these two to the front. So this is 2 ln of 5 plus ln of x. Now, of course, if that number, which now in this particular case is a 25, is a perfect square. If that was not a perfect square, if that was like, let's say 23, then you couldn't do anything. You couldn't do anything because 23 is a prime number, so there's nothing you can do there. But if it was like ln of 20, you could leave it like that, or you could, this one you can simplify differently. You could say this is 4 times 5, And then this is using the properties of logarithms is ln of 4 plus ln of 5, because the logarithm of the product is the sum of the logarithms. And then you could leave it like that, or you could take, now the 4 is a square, the perfect square, and then this is 2 ln of 2 plus ln of 5. Okay, so just keep practicing those properties. Here's another one. Do expand this logarithm. Okay, let's see. That one looks more complicated. There's more stuff going on here. So let's start by using the property that says that if I have a logarithm of a quotient, that becomes the difference of the logarithm. So this is going to be logarithm of the top minus logarithm of the bottom. Minus logarithm of the bottom. Okay. Now you have a product right here. You're multiplying x plus 3 squared times x minus 1. So that's a product. So you can expand that as a sum. So this is going to be logarithm of x plus 3 squared plus, so it's the logarithm of the first term and plus logarithm of the second term being multiplied, plus logarithm of x minus 1, and then just copy that part. And now you can take exponents and move them all the way to the front. Take exponents, move them to the front. So this is going to be 2 log of x plus 3 plus log x minus 1 minus 4 log of x plus 1, and we're done. We cannot do anything with that. Remember, I told you, if you have a sum inside a logarithm, most of the time you cannot do anything, unless you can factor it. So this is over. Okay, now we're going to do this last one here. See. All right, so let's start. This is, oh, you should try this one, actually. You should stop the video and try that one. And expand it all the way as much as you can. All right, now let's do it. This is the ln of the top in that property. Logarithm of a quotient becomes a difference of logarithms. The logarithm of the top minus logarithm of the bottom. Okay. You can take that square root and write it as a fractional exponent. So this is the ln of x minus 1 to the 1/2. So this is ln of x squared minus x, and then you can move that 1/2 to the front. Now, you might think we're done. You cannot really take that 2 and put it to the front, okay, because there's 2 terms in there. You cannot really take that 2 and put it to the front. And you cannot split that up either, because logarithm of a difference does not split up. It's like a sum. You cannot split that up. Unless, as I said a minute ago, unless you could factor it. Because when you factor it, you effectively convert it into a product. So this one actually, even though I cannot split it as is, you could factor it. So you could write this as x times x minus 1. And those brackets that I put there are not needed. I just put them in there to make it extra clear. So you can factor that as x times x minus 1. And now you have a product. And because you have a product, you can use the property that says the logarithm of the product is the sum of the logarithms. So now I can expand this and say this is ln of x plus ln of x minus 1 minus 1 half ln of x minus 1. And that is correct. There's one little thing that perhaps you noticed or not that you can still do, and that is these two terms are like terms. It's exactly the same logarithm. Uh, you have logarithm of this minus 1 half of the same logarithm. So they're like terms. It's like having something minus something, let's say y, minus 1 half of the same thing. These are like terms. Okay, so then, of course, this would give you 1 minus 1 half is 1 half y. So this is going to give you 1 half ln of x minus 1. And now that really is the end. In example 6, we're going to go in the opposite direction, and we're going to take um, multiple logarithms, 2 or 3, and condense them again into a single logarithm. We have already done this, so this is more practice. And I would recommend that you at least try these uh, before we go over them, so you should probably stop the video and attempt them. Alright, so let's go over them. So we're going to condense this to a single logarithm. So first thing you can do is take the coefficient and put it inside as an exponent. So this is log base 2 of x squared. I put the 2 inside and it becomes an exponent. And now I have a difference of 2 logarithms. You can condense that to a single logarithm by using the quotient. The difference of 2 logarithms is the logarithm of the quotient. That is the end of that. Okay, now let's condense the next one, next expression. So start again by moving coefficients inside. You move them inside as an exponent. So this is log x to the 1 half. And then move the 4 inside as well. Becomes an exponent. Log 2x plus 1 to the 4th. Okay, and now you have difference of 2 logarithms. So you can combine them like the top. You can combine them as a quotient. You can condense these 2 logarithms into a logarithm of the quotient. So this is logarithm of x to the 1 half over 2 plus x 2x plus 1 to the 4. And you could leave it like that, or you could write it, the top, as a square root. So this is the square root of x over 2x plus 1 to the 4. So either one is fine. Either one is acceptable. And remember that these parentheses right here are not really needed. So you could even write it like this. Log of x over 2x plus 1 to the 4. But however, I think the parentheses do make things clearer, more readable. So I would probably enter it like either that one or that one. All right, and the very last one. Again, if you haven't attempted this one, pause the video and attempt it. Okay, let's do it. So this is going to be move the coefficients to the inside. This is the ln of 9 to the 1/2. You move them inside as an exponent, minus ln of 4 squared. I move the 2 inside as an exponent, plus ln of x. Now, you can simplify this. You can figure out what that is. 9 to the 1/2 is the same as the square root of 9. 4 squared is 16. That's ln of x. The square root of 9 is 3. So this is ln of 3 minus ln of 16 plus ln of x. Now taking the first two, that's the difference of logarithms. So it becomes the ln of the quotient. And lastly, a sum of logarithms becomes not a quotient but a product. So that means I can multiply that by that. So this is the same as ln of 3 over 16 x. So you could report the answer like this. Or remember that you could also write that like this. 3x over 16. That's another way of writing the same thing. Okay, and in this one we said that all of these are perfectly good ways of writing the final answer. Okay, and that's all for that.